This is the solution video for section 8.2, problem number 28. Alright, so it says set up an integral that represents the volume generated when the region bounded by y equals x squared and y equals 4 is rotated about, and then there are the four different axes. Alright, so first of all, you need to come up with a graph. Y equals x squared. Alright, y equals x squared, just your basic parabola facing upwards. Alright, y equals 4, horizontal line. Alright, so now, this is given in y equals form, so it seems like it would be easiest to use dx. However, right, the directions said for problems 20 through 30, I believe, you're supposed to use the shell method. So that means for when I'm going around y equals 5, all right, so y equals 5 is a horizontal line here, so is y equals 4. So we're going to use a dy for those, right? So use dy. So dy, not du. So dy, right? So those are using the shell method, of course. And if I'm going around vertical line, x equals 2 or x equals -3, then I'm going to use a dx so that we can continue to use the shell method. All right, so shell method, 2 pi integral parentheses dy, 2 pi integral parentheses dy. Same thing, 2 pi integral parentheses dy, sorry, not dy, dx for that one, and then 2 pi integral parentheses dx for that one. All right, so now, all right, let's see, for part A, y equals 5. All right, so y equals 5 is up here. All right, so I'm going to use a different color so we'll be able to see it a little bit better. But remember, the dy is y units from the x-axis. All right, so how do we figure out the distance from 5 to the dy? All right, so you're going to take the upper thing, which is 5, and you're going to subtract the lower thing, which is y. All right, so that's the radius. The height, remember, is going to be the upper boundary minus the lower boundary. In this case, the right-hand boundary of the dy minus the left-hand boundary. Now, it's important that you remember, y equals x squared also means that x equals plus or minus root y. So it's important to remember that the right-hand boundary is positive root y minus the left-hand boundary, which is negative root y. Okay, it's important to remember that these must be in x equals form if you're going to use a dy. All right, now I'm integrating from what to what? I'm integrating from the lowest y value, which is, of course, y equals 0, to the highest y value, which is y equals 4, right? So 0 to 4. All right, so that's part A. Part B, y equals 4, that's actually just the upper boundary. But if we're using the shell method, it doesn't really matter that it's a boundary of the region. We're just going to take that upper thing, which is 4, minus the y, so just like that previous one. And then the height of the dy, it's actually the same, right? Root y minus negative root y. And then we're going to integrate from 0 to 4, all right? So that's part B. All right, now, part C. If I'm going to use a dx, remember that means I need to be in y equals form. All right, so now the dx is going to be parallel to the axis of rotation, right? So x equals 2 is on the right side. So remember, the dx is x units from the y-axis. So how do we figure out how far it is from x equals 2? We take 2 and we subtract the value of x, right? Because the 2 is on the right. All right, and then we take the upper boundary of the dx, which is 4, minus the lower boundary of the dx, which is x squared. And then we're going to integrate from left to right. So how do we know how far left this goes and how far right this goes? Well, remember, if y is 4, then 4 is equal to x squared. So then that means that x would be plus or minus 2. So this point is -2, 4, and this point over here is +2, 4. So we're going to integrate from left to right, so -2 to +2. All right, and then over here, now x equals -3 is on the left side of the region. So how far is the dx from x equals -3? It would be x minus -3. And then the height of the dx, once again, is the same, 4 minus x squared. And the limit's -2 to +2.